Welcome back, students. This is the session 5 from the playlist of IIT JEE Advanced Part 2. The topic is static equilibrium, and for this session I have taken one question which is written on this board, and here we have to find the location, nature and magnitude of a charge which is required uh, for attaining the static equilibrium of the above system of charge. Now this system of charge is placed in free space, and so here this is a regular sided hexagon, and charge Q is placed at the corners of this regular sided hexagon as shown in this figure. So I have already drawn the direction of the electrostatic force which is being exerted on this charge Q at F due to these 5 charges placed at the vertices of these of this regular sided hexagon, and I have done that in order to save the time. And here this Fe is the direction of the electrostatic repulsive force because of this charge Q at E. This Fa is the direction is the electrostatic repulsive force acting on this charge Q at F due to this charge Q at A. Similarly, Fb is the electrostatic force due to this charge placed at B, and Fd is the electrostatic repulsive force due to the charge Q which is placed at D, and Fc is the electrostatic force electrostatic repulsive force due to the charge which is placed at C. And so we have to find the magnitude, location and the nature of the charge which is required in the vicinity of this this regular sided hexagon in order to attain static equilibrium of the above system of charge. The word static equilibrium means that the net electrostatic force acting on each charge should be equal to 0. Only then we will be this system of charge will be in a state of static equilibrium. So now the each side of this hexagon is equal to A. Now we know that each interior angle of a regular sided hexagon is equal to 120 degree, because the value of each interior angle of a regular sided polygon is equal to n minus 2 into n divided by n. So here n is equal to 6. So if you put the value of 6, then you will be getting the value of each interior angle as 120. Now if this angle is 120, now this side and this side are equal, so this angle and this angle will be equal. So this is 120, and the total in the value of the total the value of the interior angles of a triangle is equal to 180. So this is 120, this will be equal to 30, and this will be 30. Similarly, this angle will also be equal to 30. Now this is 30 and this is 30, so this angle, that is BFD, this is D, will be equal to 60 degree. So I have already drawn this these angles. I have already denoted these angles in order to save the time. Now if this angle is 30 degree, so the angle between the direction of FD and FA, this will be equal to 30. The angle between the direction of FB and FA, this will be equal to 30, and the angle between FD and FB will be equal to 60 degree, because this is 60 degree. So this is an alternate angle, so this will be also equal to 60 degree. Now I have denoted this R. Now what is REA? REA is basically the resultant of E and A. That is the resultant of FE and FA. And so I have denoted it as REA, and RDB is the resultant of this FD and FB. Now, since the magnitude of FE and FA will be equal, because the magnitude of the charges are the same, and the distance between this point F and A and the distance between this point F and E are equal, so FE will be equal to FA. Similarly, FD is also equal to FB. Now since FE is equal to FA, so the resultant of FE and FA will be bisecting the angle between FE and FA. That is, this angle is the angle between FE and FA is equal to how much? 60 plus 30 plus 30, that is equal to 120. So the resultant will be passing, will be bisecting this 120 degree angle, and it will be directed in the direction as given by this arrow. So this arrow is basically giving you the direction of the resultant of FE and FA, and it will be along the line joining C and F, and it will be directed on the left hand side of this charge Q, which is placed at F. Similarly, the direction of this FD and FB will also be along the line joining C and F, and it will be directed on the left hand side of this charge Q as indicated by this arrow. FC, because both the charges are like charges, so therefore this charge Q will be experiencing a repulsive electrostatic force, and its direction will also be along the line joining C and F, and it will be directed on the left hand side of this charge Q. So all these three forces will be acting along the same line. So simply we have to find the value of R, EA, RDB and FC, and then it will be first. Then we will add all these three forces, and we will be finding the resultant electrostatic force on this charge Q, which is acting on this charge in the direction given by this arrow, that is on the left hand side of this charge Q. So let us find the value of REA, RDB and FC. Now FC, first of all let us find the value of FC. See, this is A, this is 30 degree. So based upon this, FP will be equal to what? FP will be equal to, based upon hypotenuse, that is A cos 30, which is equal to A root 3 by 2. So FB will be equal to A root 3 by 2 into 2, which is equal to A root 3. So FB is equal to A root 3, first thing. Similarly, now we have to find the value of FC. See, I will just draw here one perpendicular from here also, like this. Now this is A. Now this angle, that is BFD. BFD is equal to how much? It is 60 degrees. So this angle, this one, that is angle BFC. Angle BFC will be equal to 30 degree. BFC. Now this is 30 and this is 30. This is equal to 60 degree. So based upon hypotenuse, this will be equal to, that is, I'm just trying to calculate the value. Let us say this point is M. So FM will be equal to A cos 60, which is equal to A by 2. Cos 60 is equal to 1 by 2. So FM is equal to 1 by 2. Similarly, if I draw here one perpendicular from here, that is the MN. So NQ will also be equal to NC. NC will also be equal to A by 2. So this A by 2 plus A by 2 plus this A. So FC is equal to A by 2 plus A by 2 plus A, which is equal to 2A. So FC is equal to 2A. Now what I will be doing is, I will first of all find the value of the electrostatic repulsive force because of the charge placed at C on this charge Q placed at F. This is equal to, this will be equal to 1 by 4 pi epsilon naught. Now for the sake of convenience, what I am doing is, I am just denoting 1 by 4 pi epsilon naught, which is as equal to K. K is a constant, into Q square divided by the distance between them, which is equal to 2A. So 2A whole square will be equal to 4A square. Now the resultant of FE and FA is REA. So REA will be equal to FE square plus FA. Now FA and FE are equal, so I will be substituting the value of FA as FE square and 2 times FE into FA, so this is also equal to FE square into cos 120, because this angle is 30, 30, 60, 60 and 60, 120, and cos 120 is minus 1 by 2. So this will get cancelled out. So finally REA is equal to FE square under root of FE square, which is equal to FE. So here I will be writing the value of F and so FE RE is equal to FE, and FE is equal to K Q square divided by A square, and REA I will just write it here now. That is the resultant of FE and FA is equal to FE. Now we have to find RDB. RDB will be equal to under root of this FD square plus FB square, FD square plus FB. Now FB and FD are equal, so I am just substituting the value of this FB as FD into 2 times FD square into cos 60. Now cos 60 is equal to 1 by 2. So this will be equal to FD square plus FD square plus FD square. This will be equal to root 3 FD. So R dB is equal to root 3 FD. So REA, RDB and this FC. Sorry, FC we have already found. Now FE is equal to KQ. Now we have to find the value of now FD. Now FD is equal to K Q square divided by FD. Now FD is the this electrostatic repulsive force because of the charge Q placed at D, and this distance which we have already found, that is FB is, now since FB is equal to FD, so FB was equal to A root 3, so this will be equal to A root 3 whole square. This will be equal to K Q square upon 3A square. So FD is equal to K Q square divided by 3A square. So the resultant electrostatic repulsive force on this charge Q due to these 5 charges will be acting in the direction as indicated by this arrow. This is the arrow, and this means the electrostatic repulsive, the direction of the electrostatic repulsive force will be along the line joining this point C and F, and it will be directed away from this charge on the left hand side. So resultant electrostatic force on Q at F, this will be equal to, this is FC square, which is equal to K Q square divided by 4A square plus now this plus R EA plus R dV, which is equal to KQ square upon 4A square. Now REA. Now RE is equal to FE, and FE is equal to KQ square upon A square. Okay. And plus RDB. RDB is equal to root 3 FD. Now root 3 FD means FD is equal to KQ square upon 3A square into this root 3. So this will be equal to root 3 is there, root 3 upon 3. So what I will be doing is I will be simply just multiplying the denominator and the numerator by root 3. So I will be getting the value as K Q square divided by root 3 A square. So this is the resultant electrostatic force on Q, on the charge Q which is placed at F, and this force, the direction of this force will be along the line joining this point C and F, and it will be directed away from this charge, and it will be on the left hand side of this charge Q as indicated by this arrow. So the total value is, so this is the total value of this is the resultant electrostatic force on the charge Q at F. Now this charge will be in a state of static equilibrium when it experiences an electrostatic force in the opposite direction, and its magnitude should be equal to this value. And now this is only possible when I place a charge at the center of this hexagon, and it should be a negative charge. Let us say the magnitude of the charge is capital Q, and it should be negative charge, because if it is negative charge, this charge will be experiencing a electrostatic attractive force. It will be an attractive electrostatic force, and its direction will be given by this arrow as I have. It will be given, the direction will be given by this arrow, and so the resultant electrostatic this repulsive force, because of these 5 charges, is directed on the left hand side of this Q. And if I place a negative charge of some magnitude at the center of this hexagon, then this charge will be experiencing a electrostatic attractive force, and it will be directed along this line, that is along this line joining F and C, but it will be directed on the right hand side of this charge Q. And if both these two forces are equal, then this charge will be in a state of equilibrium. So now the electrostatic attractive force because of this charge Q, capital Q, on this charge small q will be equal to K Q, capital Q, divided by the value of this we have already found, that Fc is equal to 2A. Fc was equal to 2A. So this FO will be equal to A. So this will be so the distance between this charge, this negative charge minus this Q and this small q will be equal to A. So this will be equal to A square, and this has to be equal to this electrostatic repulsive force on account of these 5 charges. So I will be taking here the LCM. So this is equal to 4 root 3 A square, and this will be equal to, KQ square can be taken as common. So in bracket I will be getting as 4A square. This will be equal to 4 root 3 A square. So this will go to 4, this will go to root 3 plus A square plus 4 root 3, and this will be root 3 A square. So this will go to plus 4. Okay. So from here K and K will get cancelled, Q and Q will also get cancelled, A square and A square will also get cancelled. So the magnitude of the charge which needs to be placed at the center of this hexagon will be equal to, Q will be equal to Q small q in bracket, this is 4 root 3 and this is 4 root 3 and root 3. So this is equal to 5 root 3 plus 4 divided by 4 root 3. So this is the magnitude of the charge which needs to be placed at the center of this hexagon, and Q will be a negative charge. Q will be a negative charge, and its magnitude will be equal to small q in bracket 5 root 3 plus 4 divided by 4 root 3. So I think you must have understood the solution of this question, and the only thing is that here we have to find the resultant force on this charge due to these 5 positive charges which are placed at the vertices of this hexagon. And finally what I have done is I have placed one negative charge at the center of this hexagon, so that this electrostatic repulsive force gets balanced by a electrostatic attractive force. Now, because of this symmetry, this resultant force which is acting on this charge q at F will be the same for all these 5 charges. So, this charge q, if I place a charge q of magnitude this, and if it is a negative charge, then all these 5 charges will also be in a state of static equilibrium. So, the answer is the magnitude of the charge is q in bracket 5 root 3 plus 4 divided by 4 root 3, and it should be a negative charge and it will be placed at the center of this hexagon. So thank you very much for joining this session, and in the next session I will be coming up coming up with another question which will be from the chapter of electric charges and field, but the topic will be different. So till then, have a nice day. Bye.